Hello, this is John from caveofprogramming.com, and this is a tutorial on string builder, string buffer and string formatting in Java. And we're going to need these concepts before we look at things like the dot equals and the toString methods in future tutorials. So I've got a main method in Eclipse here, and I want to start by remarking that in Java it's common to do things like this. I create a string, call it info, let's say, and I'll set that equal to an empty string, and then I'll say info plus equals my name is Bob, and then let's have info plus equals and then just an empty space, just a space, and then info plus equals I am a builder. So if I output this text now, to add the semicolon there with a sysout info, it's going to say my name is Bob space I am a builder. Now this is actually quite inefficient, and the reason for that is that in Java strings are immutable. Once you've created a string, you can never change it, and it looks here as though you're changing the string. You start off here with a string that's equal to just nothing, and here it seems like you're appending to it some text and some more text and more text and outputting it, but in fact what is happening is info is initially set to an empty string, and this empty string is going to be a empty string for the rest of its life in this program. What's happening here is we're creating a new string made from this empty string plus this text, and we're reassigning the info variable to it. And here we are creating a new string made from all the previous text, this and this, where we are and this space, and then we're reassigning that to info. So basically every time you do this, you're not changing the original string, you are creating a new string, which is somewhat inefficient. And if you've just got a little program and there's just a little bit of this going on, it doesn't matter. But if it's a big program, or you're doing this in a loop, let's say, or you're doing it in lots and lots of different places, then this could slow down your program or maybe use a lot of memory. So to get around that, we've got the StringBuilder class, and the way StringBuilder works is, and let's first put a comment on here saying inefficient. Has inefficient got one N or two N's in it? I think one. Okay. Now the proper way to do this is we create a string builder object, I'll call it SB, set that equal to a new string builder, and you don't have to supply an initial value for it, but you can if you want in the constructor here. So this string builder is going to be initialized with this string, and now to add text to it I can say sb.append, and let's have my name is Sue, and sb.append space like this, and sb.append I am a lion tamer. And what I'm doing here is this string builder is having text appended to it, but in doing the append we're not creating a new string builder, we're just literally modifying the contents of the existing string builder, which is more efficient than doing this where we create a new string every time. And finally, to get my text back, I can do sb.toString. So if I do, let's say, sysout sb.toString, that will get me the text that this string builder now contains. So if I run that, it's pretty much the same as you get from doing this, except that it's more efficient. So let's put a comment here. More efficient. And that's really the whole point of StringBuilder. It's really just to give you a more memory efficient way of appending text. And there's nothing really more complicated to it than that. There is, however, a kind of shortcut you can use, because the append method returns a reference to the StringBuilder object itself, meaning you can use method chaining. And what that looks like is I can say StringBuilder, let's just call this S equals new string builder, and you can do stuff like s.append. My name is I don't know, Roger, and then you can say dot append space, or you could put string variables in here in these appends, of course, and append I am a skydiver, exciting professions. And again, it's just the same. So if I do sysout now, I can say s.toString to actually get the string, and if I run that, the same again. So I've formatted this in a way to kind of make it look nice on the screen, but really all I'm doing is just chaining methods, because append is returning a reference to this, so I can call append on it again like that. And that's basically it. There's also a class called StringBuffer, and StringBuffer is just a thread-safe version of StringBuilder. So if you're creating multi-threaded versions and you need a string builder that's safe to access from multiple threads, well, I can't say I've ever done this myself, but apparently what you would need to use would be StringBuffer. And StringBuilder is historically more, it's newer than StringBuffer. So in older code, you'll see references to StringBuffer rather than StringBuilder, but they are exactly the same. It's just that this is more lightweight because it's not thread safe. So that's that. And what I also want to show you in this tutorial is some stuff about advanced string formatting. So we've already seen that in strings, let's put a comment here, formatting. In strings you can do stuff like I could embed tabs and \n in it, new line characters, by just using backslashes. Well, so for example, I can say here is some text, and I could say \, where are we? I've got a new keyboard which is I'm still not used to, \n, so that's a tab. That was a tab, and let's have a new line here, \n, that was a new line. So we've already seen in previous tutorials, I think, the \t and \n, which are quite handy. \t is a tab character, \n a new line character. And you can also control new lines, of course, by println will output a new line after the end of your text, while print without the ln won't. So if I run that, if there was some text after this, sys out more text, then if I just do print, I'm going to get this text on the same line, whereas with ln it would be on the next line like this. So that's pretty simple, but you can also use there are some methods that take a string format, and an example of that would be if I do sysout here, then I can change this from println, print line, to printf, print format. And the way that works is you can have a string here, and you can embed in it special formatting characters, and the two most useful, maybe three most useful, are Firstly, if you want to format a integer here, I can say %d, and I can put I can pass this an extra argument with a value. It could be a variable or just a literal value, as in this case. Let's say 5. And what's going to happen is printf is going to look for formatting characters here, and then for each formatting character it's going to look for an argument here, and it's going to put this value in here, except it's going to replace this %d with this. So d stands for, actually I don't know, but it means number. So let's have another one in here. Total cost is such and such, and then number, or let's say quantity is %d. Now I've got two formatting fields in here, 2%ds, so I need to pass two arguments here. So let's say 5 and 120. And if I run that, it says total cost 5, quantity is 120. And you might be wondering what the point of doing that is, rather than using, concatenation. Well, these formatting characters allow you more control than mere concatenation would do. So let's also put a new line on the end of there, because printf doesn't, unlike println, printf doesn't output a new line on the end. And it's important to kind of separate this mentally. So here I've got 3 characters in a row, %d, semicolon, but the %d is a kind of self-contained formatting character, and for every %d you've got in your format string, this is the format string, you're going to have an argument here to replace it with. So %d, the most useful thing you can do is you can, if you want, specify a width to output this in. So I could say here 10, or maybe let's have it here, and that's going to mean that this kind of value is output in a field that's 10 characters wide. So if I output that, you can see it looks like this. And you can, if you want, you can left align it in that field by making it -10, like that. So let's say you've got a loop for int I equals 0, I less than 20, I plus plus, and you could output here. You could say sys out, and I'll change this to from a print line to a print format, and I'll say here let's output %2d and then a colon, and I'll have some text here. I don't really know what, but some text here, let's say, and then let's just output I. Now if I run that, and let's also put a new line here, \n. If I run this, the great thing about it is you can see down here that it all lines up, so that if I'd use concatenation here, because single digits obviously take up less width than double digits, this text will become misaligned when I got to 10. But here, because I've said, okay, print them all using a width of 2, it's going to all be nicely aligned, and that's kind of what it's used for. I could also, of course, put a negative in there and then get the numbers to align to the left if I want. So there we go. So the way to read this is there's always a %, and at the end there's a single character that specifies what kind of thing you're formatting. Here I'm formatting integers represented by D for some reason, and in the middle you can have extra kind of flags that specify other things about how to format it. Now another really useful one is if you just want to put strings in there, you can use %s. So %s, and then I've got to supply another argument here. Here is some text. So if I run that, it's going to say here is some text down here. you've got to make sure that you have as many arguments as you've got formatting characters, formatting fields. And probably the most useful of all is the floating point formatter. So if I say here sysout, let's see, total value, let's say %f. Now %f means floating point, so I can put, for example, 5.6 here. Let's have a new line there as well, \n. And I'm going to just put some comments on here. So formatting integers, and here let's say formatting floating point values. And if I run that, so I've got an error here because I forgot to change that to print f. So if I run that, it's going to output my my floating point value here with a default number, with like a default precision. But the floating point formatter is really flexible, because if I say between the % and the f, I can give it the number of decimal places I want to use. So let's say 0.2. So you need a dot and a 2 or however many decimal places you want. And if I run that, it's now got 2 decimal places. And just to illustrate that, if I have more values here, it makes no difference. It's still going to say, it's just going to give me 2 decimal places. And you can see actually it's also rounding off my value. So I've got 5.687, and it's because I've said output 2 decimal places, it's rounding it to 5.69, which is really handy. And you can combine that with a width if you want. So let's have another one here, and let's say just give it a value here, and I'll have it to 1 decimal place, and before the decimal point here I can have a separate width field that specifies how many characters to use to output that in. So let's say 10, and if I run that, actually maybe that's a bit much, let's say well, if I've got 1 decimal place and I've got 3 digits here, in total that's going to take up 5 characters, including the point. So if I say 5 there, it's going to output with no extra space around it. But if I have 6 here, then, and it's going to write a line in this space here. So the 6, the width here includes all the characters that you're outputting. So the ones before the decimal point, the space for the decimal point itself, and the characters after. I've just got 1 value after the decimal point here. And it's right aligning within that field, and it's left padding it with spaces. And if I want it to align it to the left, I can put a negative there, and now it will output a space after. I hope that's reasonably clear. I'm going to put this code on caveofprogramming.com so you can take a look at your leisure. And in the next tutorial, we're going to start looking at the methods of the object class, I should say. Like, for example, the dot equals and toString, as I say, which are kind of standard methods that you need to know about. And after that, we'll go on to look at stuff like inheritance. So join me again next time, and until then, happy coding.